Cloud is all about choice. Take full advantage of multi-cloud with Couchbase, a geo-distributed, cloud-native data platform built to power your business-critical applications. Avoid cloud lock-in and open up a world of possibility. Start a revolution with Couchbase. Learn more at couchbase.com/cloud.
Hello and welcome to the InfoQ podcast. My name is Wes Rice and I'm the host of the podcast and chair of the QCon software conferences brought to you by InfoQ. The next conference is in New York, QCon New York, June 27th to 29th, and it'll feature 15 full-day tracks that cover everything from microservices to machine learning and AI. Hope you can join us. Today we're talking to Pam Selle. Pam Selle is a software engineering lead at IOPipe. IOPipe works on serverless monitoring. You might know her from some of her talks and books. She did a book called Beyond the Resume, How to Get Your Next Job as a Developer. She did a book and talk called Choosing a JavaScript Framework. And at OSCON last year, she did a talk on Serverless Revolution for JavaScript developers. She has an upcoming talk at Motorama, June 4th through 6th in Portland on Serverless Observability. So today we're going to be talking all about observability, kind of serverless. We're going to be talking about some of the differences between serverless observability and how you might think of observability in a traditional application, whatever we decide that is. We'll talk about a variety of different things. So thank you for joining us. Pam, welcome to the InfoQ podcast.
Thanks for having me.
So there was this lightning talk that you did. It was like 4 or 5 years ago. Let's see, I'm going to do this without cussing. So it's Go the Pluck Home was kind of the title, so you can imply what that means. I loved it, by the way. But why do you feel that particular lightning talk resonated with so many people?
Yeah, I find it interesting. Someone told me recently that they found it recently on a site called selfcare.tech. And I found that interesting because I did this talk, I think it might have been in 2009, actually. And so it's apparently aged very well and continues to resound with people. I still get people pinging me about it. And I'm glad that it resounds with people. I wrote it and performed it at a time when I realized that other people in the industry or in my network weren't expressing the same opinions that I had about how to deal with not working all the time and really creating boundaries between your day job and what you do. And so it's very entertaining. It's only 5 minutes. And so I think it resounds people for that kind of that polemic reason of it's a catchy title and thing to watch. But I find it interesting that it seems to continue to resound with people.
It does. I like one of the things in there that you talked about was as a leader, people are watching you and you need to go home too.
Yeah. And, it's funny how things come back to bite you because, that's now I'm in a leadership position and I am taking that advice myself and I watch it happen in terms of there's this pattern that teams reflect their leadership for the better and the worse. And that goes from work-life balance to any of your personality tics and things like that. And so it has been interesting, in the last few years, moving into a leadership position.
So tell me about IOPipe. I mentioned you work on monitoring observability, but tell me more about the company and the types of work that you do.
Sure. So we are a Techstars graduate company. We've been around for a few years now, which is it's been an interesting ride. And we focus on developers in serverless compute and helping them with observability, with monitoring, with instrumenting their functions. And we started from seeing that this serverless thing was going to be a thing. It's really a new way of looking at cloud and operating in cloud that we think is very revolutionary. And as you noted, I have some talks from recently, like I was at OSCON last year talking about why I think that it's a revolutionary movement. And so at IOPipe, what we focus on is focusing on anything new. That means that it's new and it's great, but of course there's challenges in it. And so we work to help developers overcome those challenges and help them be more productive, even more productive than they already are once they've moved to the serverless model.
So everybody's got a favorite story about like the impact of serverless, why it can really revolutionize a company. What's your favorite story?
I really love Coca Cola's example. And so they were at reInvent and talked about the productivity gains of their development team. And that really sticks with me in terms of why you consider serverless. Why would you consider operating in a different kind of cloud? Your current cloud works just fine. But when you see the numbers on how much more developers are able to get done when they change to this new kind of model, I was really impressed when Coca-Cola was talking about the gains in productivity that they had, that their developers were so much more productive. They went from 39% of their time working on business projects, that is, things that are concerned with the business versus, say, technical investment things, carrying and feeding of the machines. They went from 39% to 68%. That's a huge gain in productivity. And then they went from 24% of unplanned work. So, the machines are crying. Oh no, let's do something about it, to 6% of unplanned work. And kind of fits in with how we manage our time is the ultimate limiting resource in the world is our time. And so the fact that a new cloud compute model can have such an impact on developer productivity is my favorite. It's a serverless success story. It allows people working on it to get more done.
Yeah, focus on the actual business logic that you're the expert in, not the, what does Amazon call it, the undifferentiated lifting of supplying that business logic.
Yeah, exactly.
So you mentioned that your whole space is observability. In Portland, you're going to be talking about observability with serverless. So let's kind of talk a bit about that. How is observability different when you're talking about serverless functions rather than, again, whatever this traditional kind of mindset of developing applications is?
Yeah. So in serverless compute, it's when you think about observability, the promise of serverless is supposedly, there's a saying that no server is easier to manage than no server. And as you move to serverless and you get to, hopefully care less about the machines that are running your compute, the thing is that they are ephemeral and they go away. And so when you do want to know things, a lot of the usual tooling that you would use in order to expose information from your system to the outside world, the core of observability, I want to know things about my system, those tools aren't available. And so you have to think about, how am I going to get information from a system that's no longer there? And the answer is that you have to think about it ahead of time, which is, what do you know to observe until you know what to observe, the unknown unknowns. And that's always a challenge. And I don't know that anyone's going to solve that anytime soon. But in the meantime, you can do things like collect information about your system at runtime and save that information and use that information in order to expose information from inside your serverless system to yourself outside afterward, to your business partners, all those wonderful things. And it's you have to do it a little bit differently than you would in a normal application where you can have a constantly running agent sending that data, where you can, go in at a machine and poke it, where a machine is long running, and if it's not behaving, you can, kill it and replace it with another one. Those standard operating methods are not the way that you do things in serverless. Your function is loaded into a container. This is all done for you by the platform. That container will, whether you like it or not, change about every 4 hours. You call that a cold start. And that container could also change for other reasons, such as you have an error or something that means you need to bail out. Maybe we're still investigating and very curious about how things like noisy neighbors have an impact on serverless operations, because you are operating a container. And so that means that, who knows who's next to you? How isolated are you from each other? And can you be impacted by someone else in your same infrastructure? These are still things that we're investigating. And this, it's a newer space, and we're still exploring these as, the benefits are great, but, with any great change, there's new challenges as well.
Sure. So I want to jump in here in a minute and talk about kind of life cycle events that you recommend and different things that you really should be observing and monitoring in serverless, so that you have that ability to kind of recreate that ephemeral environment that kind of went away. But before I do that, I kind of wanted to talk about, like, infrastructure. When you're building serverless applications beyond just pushing the zip file, what are people using to actually monitor their apps? Is it all just CloudWatch, or are we talking some cloud deployed Elk stack? Are we talking about third-party products? What is the state of the art for the infrastructure for logging, monitoring, and alerting?
So for monitoring and alerting on serverless, you of course have access to CloudWatch or whatever cloud you're on. But as many people know, that's, you might not want to trust your cloud platform to tell you how your cloud platform is doing. So of course there's a few different options. There's the Elk stack is fantastic, but the tricky bit is that if you're the kind of person who's going to serverless, then why are you going to build out a whole monitoring stack? To me, I find it confusing when I see people doing it because they seem somewhat diametrically opposed to, the separation of concerns of, I decided I want to do the serverless thing because I want to spend more time not building the same thing everyone always builds, such as, a monitoring stack. So in that, there's, because serverless doesn't just apply as a trend word, doesn't just apply to function as a service platforms. It applies to this whole ecosystem of the idea of letting other people who've solved problems solve the problems. If I never have to write authentication again, I would be really happy because it's a solved problem. I've written it multiple times. There's nothing creative about it. And it's not solving a new business problem. And so with that, I think of third-party monitoring solutions as kind of part of that ecosystem. And so, of course, IOPipe is one of these. There are other ones. I believe there's Thundra as well as Dashbird. They have different approaches. But in my opinion, if you're going to do serverless, it makes sense to go ahead and use a product for that. If you're buying into the separation of concerns, then buy into the separation of concerns.
Well, let's talk about lifecycle events. When you're monitoring a serverless application, what types of events should you be kind of emitting from your system? Obviously, errors and things that are going to happen, but just talk to me about kind of how you start to plan what should be monitored with a serverless application.
Of course. So I find it interesting in terms of monitoring for serverless because it can be what I would like to see, and this is not necessarily what I'm seeing yet. I would like people to carry through and care more about business events in their function, in that the platform is taking care of, it's starting your container. So you can, pay attention to cold starts. That is, if there's any technical event that you should probably care about in functions as a service environments, it's probably cold starts, which is the first time that your function is loaded into a fresh container, making sure that that's fast enough for, the percentage of load that is going to be affected by that. Make sure it's good enough. When you've got that, I would love to see people focus more on events related to, because this depends on how you've organized your functions. Some people have functions that, say, one super function that is at the end of many different API calls. And I believe Nordstrom has an example of that. But I would love to see people do more monitoring around that, around differentiating between what your function was doing when something was happening. And that's how you expose more value to the business stakeholders. The business stakeholders don't really care that, the container died. They care that, something happened when someone was trying to complete a sale, right? So trying to think more about the business event and less about the container event.
So what about like a serverless function can run for 5 minutes? There's memory caps. What about like tracking latency and things? Are there certain things that you just maybe would look at more with a serverless? Like if you're airing out, maybe you emit the fact from the context that it was running for 5 minutes or it died at 3 minutes or whatever. Are there things like that are maybe just different that you think about with serverless?
With the limitations of serverless, I think they're valuable limitations to some degree, because if you run into some of these things, then a natural question is, then why are you using serverless? Serverless architectures are best for event-driven architectures. Things should not be long-running. 5 minutes is a long time in computer time, depending on what you're doing. And if you're trying to take longer than 5 minutes, then think about why.
Maybe there's another way to do it.
Yeah, there might be another way to do it.
Okay, so let's talk about when you have an application that maybe isn't pure serverless. You have some parts of an application that, maybe a traditional AMI running with an app that's in it, and you're calling out and doing different functions that may be in serverless or even containers. Are there different things that you might monitor when you're in an AMI or a container world versus serverless? Are there different things that you need that you're emitting, or really you're just emitting events and it's all coming into a system for you to be able to sort?
So in an environment where you have serverless things playing with not serverless things, that is definitely one of the red danger zones in serverless. And it's luckily or unluckily, the best thing you can do is always have a barrier in between them of some kind. And so to me, that usually takes the form, usually, I'm sure there's, other times where this doesn't make sense. But my favorite example is you have a database. Your database is not going to flat scale like your serverless functions. And leaving your database unguarded from your serverless functions is a very, very bad idea. And this applies, it's very clear when you think about a database, but it really applies to when you have limited resources interacting with a flat scaling environment. You need to have something in between. And what we've used in the past and what we tend to see work is queues. So always some kind of queue, configuring that queue. And honestly, that seems to work to handle the problem pretty darn well. It's basically, it makes a lot of sense because queues are a core architecture piece of any event-driven system, that it makes sense that if you have events that you need to have them organized in some way and that you don't attack the rest of your system with them all the time.
So what other tips do you recommend? So on the right side, as you're writing into some type of persistent store, having a queue is a great thing. Are there any other tips that you might recommend when you're merging in a serverless and non-serverless environment that people might want to think about?
Connections is one that we've had to tune in thinking about. That darn wonderful flat scaling thing that makes it so great is also you don't want to be opening connections all the time. You also don't want to accidentally leave connections open and not clean them up. And so anytime you do have your serverless functions connecting between services, always something to be careful about, and something that we're definitely interested in thinking about that problem more of how do you optimize that, and what, it's a newer field. So we are defining best practices now of how do you handle connections in a serverless environment.
Yeah. So tell me more about it. So like when you do a code review on some of your team and there you see this kind of flat scaling world versus kind of the serverless, what are you look for connections, you look for making sure there's an abstraction between like the data source and the thing that can scale kind of crazily. Anything else that pops to mind?
We think about connections. We also think about cache. Something that we think about and do use from time to time is we do some leveraging of in-memory cache in our serverless functions. It can be really handy. It's one of the things that's very interesting because it's some things that I would be loath to do in a non-serverless environment. I wouldn't do it without a caching layer or something whose job it is to cache. But if you get some data and you want it to be there for the life cycle of that serverless container, in-memory cache works darn well. And I've personally been surprised at how well that works. But we still do, you got to think about it because it's that catch-22 of you use this great power with great responsibility of using an in-memory cache. What are you going to do when you have a memory leak? And how are you going to notice that it's happening? You notice that sawtooth pattern on your memory usage, or that you're getting fresh containers. That tends to be the visual of how you know there's a memory leak in serverless, because you'll lose a memory leak every time you get a new container. And so that's something where it comes in handy to use tools, and you have to use external products for this on serverless, but to use things like profiling, where you can actually turn profiling on temporarily for a function so that you can capture some data so that you can actually have that full trace in, so you can try and figure out where the memory leak is happening.
When you're talking about caching, what kind of gives you the indication of when you want to start using in-memory cache? And I mean specifically for serverless functions.
We've used in-memory cache when we talk to the database.
So when you're talking to the database, I got that part, but what is the indication that, oh, this is something we really want to consider using in-memory cache for?
If it's something that we can get from the database, say we can start making a key value store in cache of things that we've gotten from the database, as long as they're pretty small. And that way we can say, is this already in our cache or do we need to talk to the database? And so it allows us to limit how much we have to talk to the database in some of these higher load systems we have.
You just mentioned profiling. How do you really profile a system that's ephemeral in a serverless environment, short of just emitting a bunch of metrics?
Well, emitting a bunch of metrics is always an option. However, it's really nice to use the tools that we have to actually run the runtime's own profiler on itself, on your running code. That's something that our IOPipe libraries have available. Actually, we want to use them, where you can use the native profiler in Node.js, Python, or Java, and it will run the profiler and then upload the file to a data store so that you can access it later. I find it very useful in terms of you get to use the tools. It's bringing those tools that you would have in other environments and exposing them in a serverless environment. And as anyone who's had to use profiling data knows, when you need it, you always want it to be available.
So tell me about what you can do and can't do with profiling that's available in a serverless environment. Is it fully what you might consider with like a more traditional system, or are there some limitations?
So there are definitely some limitations, and they're very real. Depending on what we use in order to do profiling, you mark the start of the invocation and the end of the invocation. And you want to profile just the invocation. That's the unit of time that you want to measure. But if there is in some universe a way that things happen before the official invocation start or after the invocation end in that kind of no man's land, that is completely a limitation of serverless profiling. It won't be in your profiling file. At some point, you have to stop recording and send the file off somewhere. And so there is a gap. And that's real. I haven't run into yet the day when that has been an issue, but it will come. It's always not if, but when, with some sort of operations problem, but it's an issue.
You just talked about profiling within the context, the start and stop of invocation for a serverless function. What about when we start talking about the system as a whole, like tracing with a request that goes all the way through? I guess, what does the state of the art look like when it comes to distributed tracing with a serverless environment?
Distributed tracing gets thrown around a lot, and I think it is not really well defined before we start talking about it. So I'll say that, of saying that when I'm thinking of distributed tracing, I'm thinking of the full story of what happened across all my services in my architecture for a particular timeline, whether that's, and I think of it, say, like, someone's making, buying something, like back to, so like the simple e-commerce example. So someone's buying something. And so distributed trace for me is marking that through the system so that I can look at the full story. And doing that in a serverless environment is pretty available, I would think, using things. I'm not happy with where it's at, to be honest, though. If you're on Lambda, if you're on AWS, you can use X-Ray in order to see that full architecture picture of, because if you're on AWS, let's be honest, you're probably bought into AWS. And so you can see how all of your services are talking to each other when they hit this Lambda, what happens, hopefully X-Ray is doing this, of what that Lambda talks to. And you get that full story. When you isolate it to just talking about your AWS Lambda with just your serverless functions, you aren't going to get the full story, to be honest. So you can do what I think of as almost, there's not quite a word for it, but almost there, distributed tracing. It's not as beautiful, but it can tell a very interesting story I can tell the story of creating tracing for all of the things that my serverless function interacts with and sending data along with those requests to use some other system to tell a full story if I want. So to that degree, and in terms of what IOPipe focuses on, we do help people with tracing in the serverless environment to a great deal. You can measure anything in your application. Actually, you can measure whether it's a request or not. If you want to just see how long things are taking, you can measure that and create tracing data for that. We're also working on a upcoming feature where you'll be able to turn on automatic tracing so that any HTTP or HTTP, any network request, so that any network request would have automatic tracing data attached to it. And I hazard to call that distributed tracing because it's not sitting on your Dynamo machine. It's not distributed tracing unless it's touching every single part of the story. Otherwise, it's just, that's like, it's somewhat tracing. It's not distributed tracing. So I think I love that distributed tracing is getting so much attention, but I think it is getting so much attention because it's still so underserved.
So we've talked about a lot of things. We've talked about observability. We've talked about profiling. We've talked about tracing. When you're talking about kind of this whole space of observability when it comes to running Lambda applications or serverless functions, what are some of the things that are going to bite you that you may not expect, kind of those unknown unknowns?
The question is also, should you be in a serverless environment? So that's the thing to back up to is if you have a system that you don't need to build an event-driven architecture for, probably don't. It's the question of software, and when we decide to build something, we got to think about using the right tool for the right situation. And building an event-driven architecture, building microservice architectures is not always the best answer. If you can, I believe it's in distributed systems, they say, if you can avoid building a distributed system, do. It's really complicated. It's really interesting, of course, but if you don't need to do it, then don't. And so I think that's a key thing. If you can, then don't. That said, there are plenty of times when the reason why it is interesting is that event-driven architectures do make sense a lot of the time. And so when they do make sense, when you have unknown load, when you have events coming into a system and you say, okay, this looks like an event-driven architecture, I could probably use serverless here and it would probably be really handy for my use case because of all the gains that I get from using a provider to do my functions as a service so that they worry about spinning up containers for me and I don't have to do lots of load testing. I get to, buy into flat scaling, all good stuff. But making sure that flat scaling system interacts cheerfully with non-flat scaling systems, such as databases or any kind of limited system, even that might be an elastic cluster. Like it might be a cluster of computers that you want to make sure that your serverless system isn't causing them to have to scale up and down at alarming rates. So managing the load distributed among your system when you're doing that architecture. And of course, if you look at the limitations of the platform for AWS Lambda or other functions as a service and they don't work for you, then don't use them. I had a friend who was talking to me about his value-based framework for making technical decisions or recommending technical decisions from his architecture team. And I love that his first one is, if you are choosing between two things and one of them lets you ship and the other does not, choose the thing that lets you ship.
Good decision.
Yeah, it's a good first fork in the flowchart. So there's so many cases where serverless makes a lot of sense, but if it doesn't make sense for you, that's also okay.
Gotcha. Number one is to make sure it makes sense before you dive in.
Yeah.
All right, Pam. Well, thank you for taking the time to join us on the InfoQ podcast. If you want to hear more from Pam, she's going to be at Monorama June 4th through 6th in Portland, where she'll be talking more on serverless observability. So, Pam, thank you for joining us on the InfoQ podcast.
Thank you.